This is the video lesson for section 9-1 and 9-2 in John Allison's statistics class at Pulaski Technical College. These lessons are on correlation and linear regression. One of the primary ways we use statistics is to take sample data and try to make inferences using that sample data about characteristics of a population. That's primarily what we're going to be doing in these sections. I'm going to teach them both together. A correlation is a relationship between two variables. In this section, we're going to deal with relationships between two quantitative variables, or variables that can be represented with numbers. Most of the problems we'll be dealing with will involve an independent variable and a dependent variable, an x and a y, that will go together to make ordered pairs. We'll put those tables together, we will put those data together in tables we're going to examine the relationship between those two variables to see if it's linear. What we'll normally do is look at the data in a scatter plot with the independent variable on the horizontal axis, the dependent variable on the vertical axis, typically x and y. We'll plot these points to get an idea if there's any sort of a linear relationship between them. Most of the time, when we put this scatter plot together, there won't be a perfect line that can be drawn through all the points. But we'll come up with a line of best fit that most closely approximates the data. Lucky for us, our calculator is going to do most of the work in coming up with that line. But essentially, it's the best line, the closest line to fit the data. If these points are sort of close to making a line, meaning they're not scattered so far, if the points in our scatter plot are fairly close to the line, all fairly close to the line, then we say that there is a linear correlation. Because these points in this scatter plot are really close to making a line, meaning not very many of them are very far off the line, we say this is a strong linear correlation. Because the slope of that line of best fit is positive, we go a little farther and we say this is a strong positive linear correlation. If we had another data set plotted that in a scatter plot, if we were to draw a line of best fit here, which would maybe look something like that, we would say this data set has a weak positive linear correlation. Weak because this line isn't too terribly far off from the data. The line has a positive slope, and so it has a weak positive linear correlation. Let's say we had a data set that when we graphed its scatter plot was just really all over the place. In this case, there's no positive trend where you could draw a line with a positive slope, or no negative trend where you could draw a line with a negative slope. Either one of those would be just about as good as the other. Essentially, this data set would have no linear correlation because there's no good line that even comes close to approximating that data on that scatter plot. We can have data sets that when you plot them would have a strong negative linear correlation, or data sets that when you plot them would have a weak negative linear correlation. If the slope of the line is negative, has a negative linear correlation, or none at all. If it has a slope, if the slope of the line is negative, then we would say it has a strong or weak negative linear correlation. If the slope of the line is positive, then we would say it has a strong or weak positive correlation. You can find a line of best fit for any data set. But if there's no linear correlation between the variables, the line won't do us much good. Our goal if there is a linear correlation in the data, is to use the line of best fit. To predict y values when given x values. Now we'll learn to use our calculator to do a linear regression when we're given a data set using the calculator. We do this linear regression. This finds the line of best fit for the data, and the correlation coefficient. If you're wondering what a correlation coefficient is, we'll talk about that now. The correlation coefficient is represented by R on the display of the calculator, when we do a linear regression. Always -1 is less than or equal to the correlation coefficient is less than or equal to 1. Another way of saying that is the absolute value of R is always less than or equal to 1. In general, if the absolute value of R is close to 1, the line of best fit or the regression line, both are the same, is a good model of the relationship between the variables. The first thing we'll do is learn how to set our calculator so it shows the correlation coefficient. So before we start the regression, we're going to set the calculator to show the correlation coefficient. What I need you to do is hit second, 0, the number 0 on your calculator. That brings up the catalog in the calculator. I want you to scroll down to where you see diagnostic on. Then hit enter twice. Once you do that, your calculator display should read diagnostic on and then done. If you don't do that step, your calculator won't show the correlation coefficient when you do the linear regression. Next, we need a data set. Let's use, for an example, exercises in your book will use data from studies, different things. X's and Y's will represent specific things in the topic being studied. But for us, for our purposes to illustrate, we're just going to use X's and Y's. Our data set has 6 ordered pairs we're going to enter in the list on the calculator. X values in list 1, Y values in list 2. We've used the list before in this class, but to get to the list, you're going to hit Stat, then Enter. Your calculator display will then show L1, L2, and L3. If you have data in your list, you'll need to clear that now. To clear the data in list 1, scroll up, highlight L1, hit Clear, then hit Enter. Repeat that for list 2 and 3 if you need to. We'll get the list cleared, then we'll enter the X values from our list in order. It's important to keep all of these in order. In L1. Then scroll to the right, enter the corresponding Y values in L2. Now that we have the data entered in the list, we're going back to the opening screen. By hitting Second, Mode, then we'll do the linear regression. To do the linear regression, we hit Stat, scroll over to where it says Calc, scroll down to LinReg AX plus B. Hit Enter twice. If you correctly enter the data set in the list, your calculator display will now read linreg y equals ax plus b, a equals negative 2.34, a lot of other decimals, b equals 3.11, a lot of other decimals, r squared 0.90619, a lot of other decimals, and r negative 0.9519, and a lot of other decimals. What the calculator just did was gave you the equation of the line of best fit. The best line to fit this data set is y equals the a from our display is the slope of the line times x plus the b in our display. So in this case, y equals negative 2.34x plus 3.11 is the line of best fit. Your book denotes this with y hat instead of just y. The reason for that is we use y hat for the predicted y value. And since we're going to use this equation to predict y values for given x's, we're going to use y hat. Now, r is the correlation coefficient, and r in this case is negative 0.9519. We'll carry the correlation coefficient to 4 decimals. More than likely, this is extremely good fit for the data. If you drew the scatter plot and graphed the line y equals negative 2.34x plus 3.11, you would see that it very closely approximates the data. Because the absolute value of negative 0.9519 is close to 1, we would say that the correlation coefficient of negative 0.9519 indicates a strong negative linear correlation in the data. To use this regression line, this regression model, this prediction line, we might have a question that tells us to estimate y when x equals 10. To do that, we'll use our regression equation y hat. It's negative 2.34 times, plug in the 10, the given value of x, plus 3.11. And we'll see that y hat is negative 20.29. So the estimated value of y when x is 10 is negative 20.29. We might also see a question that would say, estimate x, or when would you expect, or what would you expect x to be when y equal negative 3. In that case, we'd let y hat equal negative 3, and we'll solve the equation for x. We'll subtract 3.11 from both sides. Negative 6.11 equals negative 2.34x. We'll divide both sides by negative 2.34. And we'll get x equals 2.61.